The fourth section of this algebra unit is also going to be review for you, and we are going to talk about graphing equalities and inequalities. So a couple of key terms that we need to review. We need to remember that slope is rise over run, and more than rise over run, it's a matter of subtracting your y's, because remember your y's are your run, or your y's are your rise, they go up or down on your axis. Your run are your left and right, which are your x's, and you subtract those values to find slope. And remember, slope is always an m. X-intercept is where we cross the x-axis. It is the ordered pair x some number 0. If you think about the axes, the x-intercept crosses right here, and every point there has the ordered pair some number x 0. This one happens to be negative. Over here it would be some positive x 0. In the same way, the y-intercept is where it crosses the y-axis. That's this point. And those equations, those points, always have the form 0y. So down here I'd go over 0, down y. Here I'd go over 0, up y. We can graph lines if we know the x and y intercepts. Now, standard form is something that we need to be aware of. If we're given an equation in standard form, ax plus by equals c, with our algebra skills, we can quickly and easily put it into slope-intercept form, y equals mx plus b, by solving for y. Why do we like that? Because it quickly and easily gives us the means we need to graph in the slope, whatever is the coefficient of the x, and the y-intercept, whatever is the constant. If you have standard form, if you let x equal 0, you get the y-intercepts. And if you let y equal 0 and solve, you get the x-intercepts. So both of these graphs, both of these equations rather, are pretty useful when it comes to graphing. Now if you go back and talk about remembering graphing an inequality, the solution to an inequality is the region. You shade half of the graph that makes the inequality true. And remember, if you have less than or greater than and equal to, you do a solid line. If you just have the less than and greater than, you do that dashed line. The equal sign says come up to and include the values of the line to make the inequality true. The dashed line says come up to, but do not use the values on the line, because if you test the values on the line, they will not make the equation true. So let's look at some graphing example. Graphing with the intercepts is great because this tells me the point 1, 0 is on the line, and this tells me the point 0, 3 is on. The x-intercept is 1. The y-intercept is 3. If I have 2 points, I can graph a line. This happens to be in slope-intercept form. So my slope is -5, my intercept is +5. Graph the intercept first, and then count your slope. This slope is -5 over 1. That means I need to go down 5, right 1. 1, 2, 3, 4, 5, 1. And that is where my line is. Remember, negative is down or left, positive is up or right. Now in this case, I could either find the intercepts or I can solve for y. I'm going to solve for y, so I have -3y is equal to -2x minus 3. Divide both sides by -3. Y is equal to 2/3 x plus 1. Now I know my slope is 2/3. My y-intercept is 1. Graph the y-intercept. Here I'm going to go up 2, right 3. Or, if you think about it, -2 over -3 is still positive. I can go down 2, left, 3, and end up the same spot. So if I go up 2, 1, 2, right, 1, 2, 3, I end up here. If I go down 2, left, 1, 2, 3, I am still on my line. In the same way, if I have a single negative, I can go put that on the numerator or the denominator, but not both. Here I'm going to switch to a inequality. For a minute, I'm going to think about this being x equal to negative 4. That is a vertical line. It's less than or equal to, so it is a solid line right here. And then I ask myself, where are x's less than or equal to 4? And that is everything on this side of the graph. This is where the x's are less than. And you go ahead and shade. In the same manner, for a minute, I'm going to just think about this as y equals negative 1/2 minus 2, because that means my slope is negative 1/2, my y-intercept is negative 2. So I can graph negative 2, I can go down 1, right 2, or I can go up 1, left 2. That's where my line is going to be. Now I go back to the inequality. It is dashed in this case. And now I'm going to teach you how to shade which side. So I'm going to do what's called a test point. And I always test with 0, 0 if I can, because it makes my calculations easier. You can only use 0, 0 if it is not on the line. Remember the definition of the solution of an inequality. It's what makes it true. This inequality divides it exactly in half. There's this half up here, or there's this half down here. Everything on one side or the other will make it true. So if I try 0, 0, and it's true, everything on the side with 0, 0 makes it true. If I try 0, 0 and it's false, everything on that side makes it false, which means everything on the other side makes it true. So I go to my original and I put 0, 0 in. So is 0 greater than negative 1/2 times 0 minus 2? Is 0 greater than negative 2? That happens to be true. Think about money. You would rather have $0 than owe someone $2. If this makes it true, so does everything else on this side of the equation. Now this equation here needs to be put into slope-intercept form. So I am going to subtract x from both sides. Negative 5y is less than or equal to negative x minus 15. Now I'm going to divide by a negative. Remember, when I divide by a negative, I have to flip my inequality, but only multiply and divide by a negative. So I have y is greater than or equal to positive 1/5 x plus 3. So my slope is 1/5. My y-intercept is 3. So my y-intercept is 3. I can go down 1 left, 1, 2, 3, 4, 5, or I can go up 1 right, 1, 2, 3, 4, 5. This is a less than or equal to, so it is a solid line. Now I'm going to go ahead and test my point, and I'm going to test with 0, 0 because it is not on my line. I always go to my original when I test. 0 minus 5 times 0. Is that less than or equal to negative 15? Well, 0 is certainly not less than or equal to negative 15. That makes it false. So everything on this side is false, which makes everything up here true. So tune in to part 2 for the rest of this lesson.